everyone on mahasarkar.co.in. In today's article, we are going to find out or we are going to study theorem of parallel axis. But before that, where this theorem is used, that is very important to understand. For that, we have learned moment of inertia, and we know that moment of inertia I is the product of mass and square of perpendicular distance of that particle from the axis of rotation. But many a time when we find out moment of inertia for different symmetric or asymmetric object, we have to go through some basic terms, basic ideologies, the distribution of mass, the distances of the particle from the axis of rotation. So sometimes it is convenient to use, instead of summation method, it is convenient to use some theorems, and therefore here we are going to go through two theorems. So let's learn theorem of parallel axis. So what is the theorem of parallel axis? So just wait. Suppose I am having this notebook and I am rotating this notebook at two different axes. The first axis is passing through its center of mass, means like this. Say if this is the first axis, it is going to pass through, say, this axis. This is the first axis through which this notebook is going to rotate. Okay, so if I hold it and say this like, then this notebook is going to rotate around this axis. Now second axis will be parallel to the first axis and passing through any point on the surface. Second axis is what? Parallel to, like this. So therefore this theorem is called as parallel axis. So first axis is passing through center of mass and second axis is passing through any point, but both the axes will be what? Parallel. Then here if I say this black marker is indicating the axis passing through center of mass and this red marker indicating axis passing through any point but parallel to that initial center of mass axis, then moment of inertia for this red point is equals to, what is that? Moment of inertia for this red point is equals to IO is equals to IC plus MH square. This mathematical statement is called as a theorem of parallel axis. We can prove it easily using some basic terms. So if I want to state it, moment of inertia about any axis parallel to axis passing through center of mass is given by sum of moment of inertia about the of that object about axis passing through center of mass plus product of mass and the square of distance between these two axes, that we are going to prove. To prove this, say we have consider a particle of mass dm situated at distance, say r0 from point C and at distance r from point O. So there is a particle at point P whose distance from the center of mass axis is C and same particle is located at distance r from the axis passing through point O. So moment of inertia about this axis is, say, IC when it rotates like this. Moment of inertia about the second axis is IO. Now by definition, moment of inertia mi of particle about point C can be given by formula. See, particle is at distance r0 and mass is dm, m into r square. So moment of inertia of that particle about point C can be r0 square into dm. Okay. So if I want to find out, if you remember the basic definition of moment of inertia, when we are considering the object is having equal distribution of masses, then instead of using summation sign, one can apply the integration sign. Therefore, I will write here Mi of body about point C, say it is IC is equals to integration of R naught square dm. Say this is equation 1. Using this, similarly, I will say similarly, moment of inertia of a body about point O can be written as Mi of body about point O. So it is IO is equals to integral of R square dm. So this is equation number 2. Okay. Now we are going to study, or we are going to prove this. To prove that equation, see this geometry. What we have done now, draw PD perpendicular on OC, which is extended to D. What I have done is I have joined O and C already, and I have extended this OC line, and then I have drawn perpendicular from that point. So it will look like this. If suppose this is the notebook, this is point C, this is point O. So I have joined this like, okay, this is say point P. So what I have done is, from point P, drawn perpendicular here, joined these 2 points. So as you can see, a right angle triangle ODP is formed here. Right angle triangle ODP is formed here, where distance between O and C is H and distance between O and D is say X. Okay. So if this is done, then what we are going to get is, now using Pythagoras theorem for triangle ODP, we can write, see, according to Pythagoras theorem, OP square can be equal to OD square plus PD square. OD square plus PD square. But what is OD? OD is OC plus CD. So I can say OC plus CD bracket square plus PD square. Expand this. OC square plus 2 times OC into CD plus CD square plus PD square. But see again, what is this CD square? CD square plus PD square can be equal to CP square according to right angle triangle CDP. Therefore, it will be like OC square plus 2OC into CD plus CP square. This is value of what? OP square, what we got. Now, we are going to multiply equation both sides, or before that I will replace values of OP, OC, CD and CP from the diagram. So it is like OP is R, so it is R square can be equal to OC square is what? H square plus 2H, CD is X, this CD is X, and CP square means R0 square. Multiplying both sides by dm, multiplying both sides by dm, we will get R square dm is equals to H square dm plus 2H into X dm plus R0 square dm. On integrating both sides, the sides, what we are going to get? Integral R square dm equal to integral H square dm plus 2 times integral H into X dm plus integral r0 square dm. Now see here few things. Distance between two axes is same, so it can be considered as constant. These values we are having, equation 1 and 2, we are having with them. So before that I will adjust these few things. H square integral dm plus 2h into integral x dm plus r0 square dm. Now see, x is the distance between that any point D and the axis of rotation passing through center of mass. We know that at the center of mass resultant distances or resultant mass is always 0. So this term is anyhow is going to reduce to 0. Integration of dm. Dm is the small particle. All the particles when added, total mass of body will become, so integration of dm will be m. So h square into m plus this will be 0 and plus use this term from equation 1, it is IC, and LHS use this term from equation 2, it is IO. Therefore I can say IO is equals to IC plus MH square. Can you see this, that we have proven the parallel axis theorem. Okay, it's very simple to prove. Just we need to keep these two things in mind. H is the distance between both the axes, whereas x is the distance of that point, any point on the surface in which it is close to the center of mass. When it is close to the center of mass, all the reflective mass around that distance x are going to be 0. So this integration is going to be 0, and this will be the definition for parallel axis theorem. Okay. We are going to learn the application of parallel axis theorem. Application, where it can be applied. To apply the parallel axis theorem, say first we have a rod. Thin uniform rod is given. Okay, I will just adjust the space. We have thin uniform rod like this. Say this is the rod, and when it rotates around its axis, so rod, say m is the mass of the rod and L is the length of the rod. Okay, and when it rotates about its center, moment of inertia about center is say given by formula ml square upon 12. The formula is given when it rotates around the center. Now if suppose the same rod is rotated about end, so if suppose this is the rod and it is rotating about the center like this, then its moment of inertia is given as ml square by 12. Okay, and now if you want to find out moment of inertia about the end of that rod, like here or any end, so if this is the axis, say IO, this is IC, distance between, now if total length was L, so this length will be what? L by 2. So I can find moment of inertia of rod. So therefore I will say mi of rod about its end can be given by parallel axis theorem. Therefore we have by parallel axis theorem, I can write IO equal to IC plus MH square. IC, what is value of IC? I have already written there, ml square upon 12. These values you have to keep in mind for all those objects which will come. H is what? L by 2 square. So ml square by 12 plus ml square by 4. We just need to take LCM. ml square by 12 plus multiply this by 3. So 3 ml square by 12. So 12 will be the common base. ml square plus 3 ml square will be 4 ml square. So 4 upon 12 will be 3. So ml square by 3 is the moment of inertia of any uniform rod of length L, mass m, rotates about its any end, first end or second end. Okay, so use such a way you can apply this for ring, you can apply this for disc, you can apply this for any sphere or any kind of object where we are going to find out the moment of inertia about any parallel axis to the axis passing through center of mass. Then one can use the parallel axis theorem. I hope you understood this article. Thanks for watching mahasarkar.co.in. Have a nice day. Thank you.